switches are one of those things that are everywhere, and we kind of forget that they even exist because they're so prevalent. There's so many things that we use on a day-to-day basis that have switches that we may not even realize. Like this keyboard, or this Pikachu controller, this little outlet controller. Using a mouse has 2 switches, and actually 3 switches. This one has. There's a lot of switches. The light switch is a switch. So there's so many different uses of switches. Some are for leisure activities like gaming, or some are more essential, like just flipping on a light, or being able to maybe turn on a TV. That's not a TV, but you get the idea. But what if pressing one of these little bitty buttons is difficult for you? Maybe you have an amputation, or maybe you have cerebral palsy. Well, these little buttons can be kind of challenging to press. Well, thankfully, there's a solution for that. Adaptive switches. Adaptive switches let you plug in your specific button into a switch adaptive device so that you as an individual can have a more customized experience, depending on what your needs are. Now, all that is really great. There's just 2 problems. The first one is that these little buttons can be pretty expensive. This little button right here is about $75 if you're to buy it new. Now, there are some insurances that might cover that, but for a lot of people that can be very unaffordable, especially if you want to play video games and there's a lot of different buttons that you might need adaptive switches for. The other problem is that a lot of devices like this little remote don't have anywhere that you can plug an adaptive switch into. So today we're going to try to tackle both of those problems by making our own little switches and then also trying to switch adapt to the device ourselves. So if you don't know, all a switch is really doing is just completing a circuit. So if you have something like this little LED wired up, all a switch is going to do is complete that circuit when you click it, and when you let go, it's going to break that circuit. Now, there are a few different types of switch mechanisms out there. There are some that have 2 pins, some that have 3 pins, some that stay on when you click them, like latch switches. There are some that respond to temperature, pressure, infrared. There's a lot of different types of switches out there. Today we're going to be focusing on one particular kind of switch, and that is a momentary switch. It's probably the most common when it comes to adaptive switches, and specifically the ones that you can find online to make yourself. All it is you click it, and it's on, you let go, and it breaks the circuit. Now, if we were to pop open a switch, we might see a little mechanism that looks a little something like this. So this little switch mechanism has 4 pins, and I've gone ahead and kind of just bent these out. So if you were to look at a switch, a lot of times when you pop it out of the box, it might have 4 little pins like this, and that can be a little confusing to people because you don't know, do you connect the wires to these pins, or do you connect the wires to these pins? And the best way to understand this is to realize that it's really just kind of 2 little strips of metal that run through the switch. So if we were to connect both of our wires to this switch, and we press the button, it will complete that circuit. If you find that your switch is always on when you plug it in and clicking the button doesn't really do anything, you might have wired it to the same pin. So the connection is going to be constant and you're not going to be able to break or form that connection when you need to. So you go to buy a switch and you realize that they're very expensive. So now you've decided that you want to try to make one yourself. Luckily, it's not too hard. All you're going to really need are 3 things. You need your switch mechanism. You need a cable, an audio cable of some sort. You can either use stereo or mono audio. I would recommend mono audio if you can find it, just because it's a little bit easier, because all it is are 2 wires. Stereo has a few more wires. You just have to make sure that you're using the right wires. And the last thing that you need is a switch housing, which you can 3D print if you have access to a 3D printer. If you don't have access to a 3D printer, check your friendly neighborhood school or library or STEM club. They might have a 3D printer, and if you're not able to use it, they might be able to help you out and print it for you. Thankfully, there's a lot of different models out there on websites like Thingiverse where you can just download the files for free and print them yourself. And some models might be able to meet your needs better than others. It just depends on what you need. But despite which model you choose, the principle of how a switch works and how you're going to put it together and make it are relatively the same. Unfortunately, you probably are going to have to use a little bit of soldering to make your switches. Soldering's not too difficult if you've never done it, and you can pretty easily learn just by watching some YouTube videos. That's how I learned. So I've linked some videos below if you are unfamiliar with soldering. Though keep in mind, soldering can be a little bit dangerous because the iron is very, very hot. It's around 600 to 700 degrees Fahrenheit hot. So if you imagine sticking your hand in a broiler, don't touch the soldering iron. In essence, soldering is a lot like using a hot glue gun, just with a few more steps. So to get things started, what I'm going to do is first bend out these little pins to flatten them out. So there are 4 pins here, but really all we're going to need are 2 pins. These are 2 pieces of metal that just kind of run the length of the switch. So when you press the switch down, it completes that circuit. So it doesn't matter which 2 we solder to, it just has to be on the same side. So it could be those 2, could be those 2, doesn't matter. But if we connect these 2, the switch will not work. So to make things simple, I'm just going to break off by bending back and forth 2 of them. So now we're just left with these 2. So this switch is going to sit straight in there, like that. But for right now, what we're going to do is solder it up. We don't need to worry about connecting or threading the wire through initially, because we can just simply put it in after the fact. Now I should note that for a lot of switches, you need to thread the cable in first before you do any soldering, because as a whole, so you're not going to be able to fit the switch through that once it's all soldered up. So first things first, I'm going to cut my wire in half. I am using a mono audio cable, so there's only going to be 2 wires inside, but you can use stereo as well. You just have to make sure you use the correct 2 wires. Alright, so I have 2 wires. It doesn't matter which way I connect these. So next what I'm going to do is strip both of these. Alright, and we are good to go. So now I need to go ahead and preheat my soldering iron so we can go ahead and tin these wires. So what I'm going to do is get a little bit of solder on these wires to help it stick to the other solder. And then I'm going to add a little bit of solder to these pins. You don't really need to add solder to these pins. You can solder directly to them if you wanted to. I just find that it's a little bit easier if you kind of tin these pins as well. Now that my soldering iron is hot, I'm going to heat the wire and add a little bit of solder to it. The wire, add a little bit of solder. I should say my soldering skills are not the greatest, but they will do. I'll do the same thing on this side right here. So now for this, because I already have solder on both my wires and the switch, I don't really need to add any more, though I could if I needed to. All I'm going to do is heat the wire and the pins, and they should melt together. Heat the wire and the pin, and then let the solder kind of flow together and then harden. And there you go. With that, you should have a working switch. And we can go ahead and test that by plugging it into something that is adaptable and clicking the switch to see if it works. Which it does. So now all that's left is for us to set it in here and hot glue it into place. So we'll add a drop of hot glue. And press the switch down in there firmly. It is a pretty tight fit, so you may not even need hot glue, but I just like to have the extra security. So I need to bend it around to fit into these channels. The nice thing about this switch is that it has built-in strain relief. So typically what you want to do is have something to take the stress off of the wire, specifically when it joins to the switch. Otherwise you could have it break off after a lot of bending. So you could just hot glue everything in place. That can be a form of strain relief. Or you can do something like this one, which is where you tie a knot in the actual cord so you can't pull it through. Or you could take something like a zip tie and cinch it down around the wire. Cinch it down tight, so that way if it's a small hole, it won't be able to pull through. So I also like to just add a little bit of drop of glue around the wires just to really hold those in place, and also just kind of provide a little bit of insulation for those bare wires. Once everything dries and is situated how you want it, all that's left is to assemble. This switch is pretty straightforward. You just take the top button, situate it into this ring, take the button, put it on top, snap it down into place, and then give it a little bit of a turn so it locks into place. And there you go. You can plug it in and see that it works. And there you go. You now have a working switch for about $2 to $3. Not too bad, but you can't plug your switch into anything yet. There's nowhere to plug into this device with this switch. So you're going to need a switch adaptive device, which can also get kind of expensive and kind of a hassle, unless you switch adapt it yourself. Most devices that have a physical button that you can press can be switch adapted. Remotes are usually a pretty good option to switch adapt because they tend to be pretty small. They usually have buttons on them. They're not too hard to take apart, and there's not a lot of extra pieces that you might mess up. Regardless of what you do though, if it has a physical button, the principles are usually going to be the same. Alright, so our goal is to switch adapt both of these buttons right here. So in order to get started, we need to go ahead and take it apart so we can see what it looks like on the inside. So in order to do this, we're going to need a female adapter of a mono audio jack. And thankfully you can just buy these on Amazon. But as you can see, we have two little buttons right here. And there are two little points on either side that we could solder to. And so what we'll end up doing is soldering each end of this wire to that switch. So what you want to do ahead of time as well is figure out where this wire is going to come out of this housing. So you can go ahead and drill a hole and feed this wire in through before you do any soldering. But because this is just for demonstration purposes, I'm not going to worry about that right now. I'm going to put this into my helping hands. That way it can hold it in place for me. Now these wires actually come pre-tinned, so it has a little bit of solder on them. So it is possible to use the solder already. What I'm going to try to do is add a tiny amount of solder to each of these points. Alright, so I'm going to very carefully touch the tip to that end and then add just a little bit of solder to that point. Same thing on this side. Heat it and then just add a little touch of solder to that point. Next, I'll take both ends of the wires and solder them to each end of the switch. And that's it. Next, what you would want to do is go ahead and test it to make sure that it works. And if it does, go ahead and do the other switch as well. Once you have both soldered up and in place, go ahead and add some strain relief to make sure that this is not going to pop off. And after that, you are pretty much done. Just go ahead and assemble it and you're good to go. You now have a switch adaptive device. So now if I hold the battery in place on the back, we can see that the original button still works and our adaptive switch also works. Now, I do need to take a second here to talk about safety. Just because you can switch adapt something doesn't mean that you should. A good example of this is a light switch. Technically, a light switch is a switch, and you could switch adapt it using the same techniques, right? The only problem is this little audio cable and this little switch are not designed to have that much electricity going through them. So unless you want to have things melt and burn and cause a fire, don't do that. Anything that has a large amount of electricity running through it, just be very careful if you are going to switch adapt it. Anything that plugs directly into the wall, just be careful in how you are switch adapting it. If it's like an on-off button on a circuit board, that's probably pretty safe. But if it's like the switch on a power strip, don't do it. If it's the power button on a vacuum cleaner and it has a lot of electricity going through it, you might not want to do that unless you know exactly what you're doing. But as a whole, if what you're switch adapting has batteries, you're probably pretty safe. Now, there are other ways that you can switch adapt something without having to solder into it. There are things like battery interrupters and some other devices, and there's a video by that guy Bud that I'll leave in the description below that I think really covers that topic pretty well. Second thing is, you always want to think about what is going to happen if your switch or your switch adaptive device fails. If the device is constantly on, is that a danger? If it doesn't respond, is that a danger? So I would avoid things like trying to switch adapt a power wheelchair yourself, or trying to switch adapt something like maybe a toaster, or trying to switch adapt anything that has some kind of essential function. So now hopefully you have a pretty good idea of how switches work, how to make your own switches, and how to switch adapt something. If you have any questions or any feedback for me, feel free to leave that in a comment down below and I'll try to get to it. Otherwise, happy tinkering.